You know that AI you talk to every day? What if it could do more than just talk? What if it could actually see and understand our physical world, not just as, a bunch of pixels, but in the same intuitive way that we do? Well, today we're going to dig into a blueprint for exactly that, a new kind of AI that's learning to leave the world of words behind and step right into reality. Okay, so let's start with this quote because it's powerful. The researchers behind this work frame the whole problem using Plato's famous allegory. Imagine you're chained in a cave your whole life. The only thing you ever see are these flickering shadows of objects on a wall. Now, you might get really good at describing those shadows, right? But you'd have absolutely zero real understanding of the objects themselves. And that, according to these researchers, is exactly where today's AI is stuck.
So what does it really mean for an AI to be trapped in this digital cave? Well, think about it. Our best models today, they can write you a beautiful poem about a sunset, no problem. But they have no concept of the warmth of the sun on your skin, or the way the colors just explode across the sky, or that feeling of awe you get watching it. It's all just symbols, totally cut off from the real physical world.
Now, this blindness is creating two huge roadblocks for AI. First, you've got the philosophical problem. As the paper puts it, text is a lossy compression of reality. It's like a really low-resolution photo. You get the gist, but all the nuance, the physics, the cause and effect, it's all gone. And then there's the really practical problem. We are literally running out of high-quality text on the internet to train these things on. It's like trying to teach someone to swim by just having them read books about swimming. Sooner or later, you've got to actually get in the water, right?
So yeah, the challenge is pretty clear. But what's the fix? How do we actually break AI out of this text-only prison and let it experience the world for itself? That is the billion-dollar question that this incredible new research sets out to answer.
And that brings us to the quest for reality. See, the answer here isn't to just, staple a camera onto an existing language model. No, the proposal is to build a totally new kind of AI from the ground up, one that's natively multimodal. What that means is teaching it to see and read at the exact same time, from the very beginning, kind of like how a human child learns, using all of their senses at once.
And the absolute key here is that it's all happening inside one single unified model. The AI is learning to predict the next word in a sentence and the next frame in a video all at the same time, in the same brain. This forces it to build a much deeper understanding of how language and the visual world are actually connected. And of course, you can't feed this new AI the same old stuff. It gets this incredibly rich diet. It gets text, sure, but also images paired with descriptions and just raw video. But crucially, it also gets something called action-conditioned video. This is so important for things like robotics. It's not just about watching a video, it's about seeing an action and then seeing its consequence. You see a hand push a block and then you see the block fall over. That is how it learns cause and effect.
Now, you might think teaching an AI to see is as simple as plugging in a webcam, but nope, it's way more complex than that. Historically, the way AI handled vision was this messy, inefficient patchwork of different tools for different jobs. And the first huge breakthrough in this paper is their solution, something they call a single universal eye.
And this is where things get really smart. Instead of that clunky old approach, one tool for understanding images and a totally different one for making them, the researchers developed this one elegant system called RAE. Think of it like a Swiss Army knife for vision. It can analyze what's in a picture and create a brand new picture, all using the same core parts. I mean, it's just a huge leap in efficiency.
And hey, the results speak for themselves. This chart basically shows that this new RAE approach consistently smokes the old methods at both understanding images and creating them. So this isn't just some cool idea on a whiteboard. It's a proven, more effective way to give AI sight. It pretty much settles a major debate in the field. A single, unified visual system isn't just possible, it's actually better.
Okay, so they've built this incredible universal eye. Problem solved, right? Well, not so fast. As they started to make it bigger and more powerful, they ran smack into a totally new and unexpected problem. It turns out, teaching an AI to see and teaching an AI to read, well, they're very different challenges, and they don't always play nicely together.
The paper calls this problem a scaling asymmetry. Let me give you an analogy. Imagine you're training a team for a decathlon. You've got a weightlifter and you've got a marathon runner. They need completely different training schedules, right? Different diets, different exercises. If you try to train them both the exact same way, you're going to end up with a mediocre weightlifter and a mediocre runner. That's the problem this AI was having.
So on one side of the coin, you have language. To get really good at the incredible complexity of human language, the AI needs a huge, powerful brain.
what researchers call high model capacity. But then, on the other side, you have vision. And to learn all the visual patterns of the real world, the AI needs to consume an absolutely insane amount of data. We're talking billions of images and videos. And these two demands create this constant tug-of-war inside the AI, with each one trying to hog all the resources. So how do you solve this tug-of-war? With this brilliant idea called mixture of experts, or MOE. Instead of one giant overworked brain, imagine you have a team of highly specialized experts. You've got your language gurus over here who are geniuses with words but know nothing about images. And then you have your vision masters, who can analyze video in a flash but can't write a sentence. The MOE system acts like a smart project manager, routing every single task to the right expert for the job. And this is just such an elegant solution, because it allows the AI to be both big and small at the exact same time. When it gets a language task, it calls on its team of language experts, and it effectively becomes this huge, powerful language model. But when it's processing a video, it switches over to its lean, mean vision experts and becomes an efficient data-crunching machine. It's this flexible, dynamic approach that just perfectly solves the scaling puzzle.
Okay, so we have a universal eye for seeing, and we have a super efficient way to scale it. And when you put those two breakthroughs together, well, something truly remarkable starts to happen. A completely new capability starts to emerge, and it really points to the future of AI. As the researchers kept training this new kind of AI, they started to notice it was developing this surprising and powerful new skill, something they hadn't explicitly programmed it to do. It was starting to build its own internal, intuitive simulation of the world. In other words, it was developing a world model.
A world model? What does that even mean? It means the AI can not only see what's happening right now, but it can start to predict what's going to happen next. It's almost like it has a little physicist and a little fortune teller living inside the machine. And the paper gives us this absolutely stunning example of it in action. So check this out. The AI isn't just looking at a photo and saying, "That's a vacuum cleaner." No, it's watching a video. It's processing the sequence of frames and understanding this object as it moves and changes through time and space. And this is where the magic happens. Based on the video it's already seen, the model starts to actually predict what the very next frame is going to look like. It's developing an intuitive sense of momentum, of physics, of cause and effect. You have to understand, this is a huge, huge leap. This isn't just about recognizing patterns anymore. This is about the AI building a genuine internal understanding of how the physical world actually works. It's the first real step towards an AI that can truly reason about reality. And the implications of this are just staggering. I mean, think about it. Imagine a surgeon getting real-time guidance from an AI that can see and understand the complexities of the human body. Or a rescue robot that can navigate a collapsed building, not just by following a map, but by truly understanding its environment. This is the future that world models could unlock. You know, for all of human history, we've basically been the only things on this planet that could really see and understand the world around us. But that's about to change. As AI steps out of the cave and into the light, it won't just learn from us. It's going to teach us new ways of seeing our own world. The only question is, are we ready to listen?